back to Spring Into Math Day. Today we're going to be taking a look at the Chapter 10 review video. So we're going to review all the topics we've talked about so far in this chapter. Let's get started. The first topic we talked about was function to linear model relationships. So you may be asking yourself, how do you write an equation based on when you're looking at a function table? Well, first thing we need to do here is recognize that we have an xy table, and that these xy table can be turned into coordinates. We're going to then need to use these coordinates to help us create an equation. So we're going to go ahead and pick a couple coordinates from our table here and get started with it. So first of all, we need to find the slope, and to find the slope we need to use the slope formula. It's been listed here for us. It's y2 minus y1 over x2 minus x1. And I picked two coordinates for us to go ahead and insert into this formula to help us find our slope for this equation. And I picked the coordinates 2, 7 and 4, 8. So we're going to put those in respectively to where they fit into this formula and then go ahead and solve. So I set it up as 8 minus 7 over 4 minus 2. And when we reduce or simplify this fraction, it gets the fraction of 1 over 2, or 1/2. We can then insert this 1/2 into our y equals mx plus b formula. Inside this formula, the number in front of the x value here is the slope, and we're going to insert 1/2 right there. So far, our equation looks as the following. Y equals 1/2 x plus b. Not quite done yet. We need to find our b part for our equation still. So again, we're going to plug in another coordinate into what we have so far. So I picked the coordinate 2, 7. And I'm going to go ahead and insert the x and y value of that coordinate into my equation of y equals 1/2 x plus b. So I get the equation set up of 7 equals 1/2 times 2 plus b. So let's go ahead and simplify what we have. Again, we have y equals 1/2 x plus b. We inserted 7 and 2 into the proper places into the equation, and now we're going to reduce. So 1/2 of 2 is 1, so my new equation so far reads 7 equals 1 plus b. Well, I'm going to go ahead and subtract 1 from both sides because I want b, the variable, to be standing alone. So when I do that, I get that 6 equals b, or we could say that b is equal to the number 6. We're going to just introduce that 6 into our equation, and we're going to be all done here. So our final equation, based on our data table, our xy table, is y equals 1/2 x plus 6. Topic 2, point and slope. So we're going to try and write an equation that has a slope of 2 and passes through the point -3, 6. Well, this is a very nice thing they gave us. They already gave us the slope, which is about half of the work we had to do. So let's go ahead and get started with it. So we're going to need to use, again, the y equals mx plus b formula. So we know our slope is 2, and the equation looks like this so far when you insert the number 2 into the proper place where the slope goes. Y equals 2x plus b. So you can see that we put our whole number 2, which they gave us was our slope, into the proper place. Remember that slope is always the number that comes before the x value in this y equals mx plus b formula. Well, we also need to use the point they gave us on the coordinate plane. In this case, it was -3, 6. So we're going to go ahead and insert that into our equation so we can solve for our b value. Now remember, our b value is where our equation crosses the y-axis when we graph it. So I've gone ahead and inserted this for us, and it looks something like this. 6 equals 2 times -3 plus b. Well, we're going to go ahead and multiply 2 times -3. So our equation now reads 6 equals -6 plus b. Well, to get rid of that -6 on the side that it stands with b currently, we're going to go ahead and have to add 6. We're adding 6 here because we have a -6, and we want that -6 to say 0, so that variable b stands alone. Now when we add 6 to both sides, we get 12 equals b. Now we have all the parts we need to go ahead and write our final equation based on the slope they gave us and the coordinate they said that the equation passed through. Our new equation is y equals 2x plus 12. The third topic we took a look at in this chapter was point-slope form. We need to write an equation in point-slope form. We need to have a few things set up in order for us to do that. But first, remember that the point-slope formula looks as follows. Y minus y1 equals m parenthesis x minus x1. Now this can be confusing, but let's walk through it together. So not only do we need the formula, we need the slope of the line and at least one point where this equation hits on the graph. So we're going to write an equation for the line containing the following two coordinates on a coordinate plane, 9, 3 and 4, 5. So first thing we need to do is start with finding our slope. And we're going to use the slope formula of y2 minus y1 over x2 minus x1. We're going to go ahead and insert the coordinates that were given to us in the original problem and solve for our slope. So it's set up, it looks like 5 minus 3 over 4 minus 9. And when we reduce this fraction, we get a negative slope of 2 over 5, or we could say negative 2/5 is our slope. Now, we need to choose a point and insert it into our point slope formula, which again is y minus y1 equals m parenthesis x minus x1. I've already inserted our slope here, which was negative 2/5. And I've already inserted our point that we're going to use for our equation. So our new equation reads as y minus 3 equals negative 2/5 times x minus 9, which sits inside a set of parentheses. So we need to start to reduce our equation from here. So again, it's set up as y minus 3 equals negative 2/5, and inside a set of parentheses we have x minus 9. So let's go ahead and learn to reduce here. So we're going to go ahead and multiply or use the distributive property with the negative 2/5, which is our slope, and multiply it by x first, which is the first item inside the parentheses. That gives us negative 2/5 x. Then we cannot forget to also distribute the negative 2/5 to that negative 9, which is also inside the set of parentheses. Now when you do this, it gives you an improper fraction of 18 over 5. So we have already taken care of the right one side of our equation, and we've used the distributive property to do so. Now, we have a setup of y minus 3 equals negative 2/5 x plus 18 over 5. We need to get y standing alone. So we need to move the negative 3 that's next to the y to the other side of our equation. In order for us to do that, we must move that 3 by adding 3 so they cancel each other out. And now it reads y equals negative 2/5 x plus 18 over 5 plus 3. Well, we can continue to reduce by adding 18/5 plus 3, the whole number 3. And when we do that, we get our final answer of y equals negative 2/5 plus 33 over 5. Topic 4, y-intercept. Let's take a look at a real-life problem. Danny drives a cab for the company that charges $90 a day for the car, as well as a one-time charge or a one-time fee of $25. They're asking us to write an expression or an equation for the cost of dollars, which we'll use the variable c to represent, as a function of the number of days, which we represented by the variable d, that the car was rented. We're going to use y equals mx plus b as a nice, easy formula for us to set up. So we know that it costs $90 per day. That $90 per day is considered our slope part of our formula. And that b value is 25 because it's that one-time fee. So again, our slope is 90 and our y-intercept is 25. What would it cost if they have a car and rented it for 5 days? Well, we know that we have c, the total cost here, is 90 times 5 plus 25. The reason we're doing 90 times 5 is because that we know that we have 5 days worth of driving to do, and it costs $90 per day. Now when we multiply 90 times 5, we get 450, which you can see just below that. So right now we have c plus 450 plus 25, which when we reduce it is going to go ahead and equal c equals $475. Topic 5 from this chapter, analyzing functional relationships by graphing. A couple of key vocabulary words we want to cover in this section. The word increase means going up, decrease means going down, the word constant rate, and we can even use the terms faster and slower to help us describe or analyze a function on a graph. So, Leo made a graph of the trip he went on. He walks to his friend Brian's house and then hires a taxi to take them to the office. This is represented by the following graph. It is split into 3 different sections. We have a section A, a section B, and a section C. Let's break apart each part of this graph to help us analyze what we're seeing. In the very first part, part A, we can see that Leo is walking to Brian's house. Now, we can see that it has kind of a constant rate. It's going up at a constant rate there. So we can say that it's increasing as well. Part B, Leo gets to Brian's house and they get a taxi. Part B is flat. That is due to the fact that they are waiting for the taxi to show up to their house so it can take them to work. Now, while you're waiting or standing still, you have a flat rate on your graph. The last part of our graph here is Leo and Brian are sitting in the taxi, and the taxi is moving at what we call a constant rate. If you compare Leo's walking speed to the taxi speed, it's pretty obvious that the taxi is moving at a lot faster rate than when Brian was walking to work. Now, we can see here that the C part of the graph is shooting up dramatically. That shows that the taxi is moving at a fast pace. That's it for this chapter review. Catch you in the next video.